Hey guys, welcome to Bar Z. My name's Stan, and today I want to talk about a little bit of indicating and an error that I found. And this would apply to here on the plate with your metrology, as well as maybe on the lathe. I know a lot of guys are using indicators that have a ball nose. Now I've got a square here that's a very small diameter, and we'll draw that right here. Now, and I was getting an error, and I was using my regular Mitsutoyo indicator stylus with a little ball. Now, what you've got is basically, tip that up a little bit. You're just drawing a line. You've got two actually circular objects touching each other, and you're only contacting in one location, in one spot. And if that, as you're making the vertical sweep, if it travels left or travels right, or quite often the stylus will have a little bit of side slop in it, that's going to give you an error in your reading, and it's going to give you false readings. So what I switched to, and this would be the same if you were sweeping a round part on the lathe using the carriage. Let's say your carriage is going high or actually going low, either one. This little round ball would climb up or climb down and give you a false reading. And I'm talking tenths here. It doesn't have to be a lot, but an error still can exist. Now, how do we overcome that? I'm going to show you here in a minute. I'm going to tip the camera down, but I've switched out my indicator to a square-nosed tip. The end of it's lapped, and it's a square-nosed tip. So now we no longer have two circles meeting each other. Now we've got a circle and a square meeting each other, and it's more forgiving. This is going to become apparent on your lathe, and it's going to be apparent here, what I'm about to show you. So let's get into it. We're going to measure this little magnetic cylinder square. I'll tip you down, and you'll notice this is not my regular gauge. This is my little Federal tenths gauge. But here, let me show you that. I'm going to show you this. This is a little blunt nose, very square, lapped tip. And these just screw in. I've got roller tips. I've got little needle type tips. I've got all kinds of tips that fit this thing. So I'm going to try to get you not necessarily on the gauge, but kind of where the rubber meets the road there. I'm going to show you what's going on with that tip and that little cylinder. And the smaller your diameter is, the more apparent it's going to be. It's get us up on zero here. Yeah, and the smaller your parts are, the more apparent this error is that can exist. Okay. Oops. Okay, here we go. All right, looking good. All right, guys, that is a way that I overcame some errors that I was getting actually using the Square Master on this small diameter. This isn't that big around there. Okay, well, while we're on the subject, I guess a lot of you guys want to know what this is. This is a cylinder square that I reground for Keith Rucker. Now, this thing gave me tons of problems. When it came to me, it was hollow, and you can see I've got centers in it here and here, and those aren't pressed in. I made them a slip fit and slipped them in and used some Loctite to hold them in there. Now, and then I tried grinding it. Now I've got a hollow cavity in here, and I was having problems right here in the middle with it overheating, flooding it with coolant hard. The way I overcame that is if you look down in that center, you'll probably see a blob of silicone. And we're all done now. We're done measuring. We're pretty happy. And we filled that cavity with coolant. That little blob of silicone in there is holding back a bunch of silicone, or holding back a bunch of coolant, and there it comes. So let's get the silicone out of the way. Hopefully I got it all and it doesn't block the hole on its way out. But I sat there with a hypodermic needle and filled that turkey up. And I'm just going to let it sit there and drip. It's dripping now. So that's the way I overcame my center problem on this thing. Was I actually had to fill that cavity with coolant and spray it hard with coolant on the outside. And I was actually talking to Robin Renzetti, and he said to thin my wheel. So I was using a 1/2-inch wheel, and I took about two-thirds of it out. So I was down there. I had a tiny little bit of wheel touching it and flooding it hard with coolant. So we're going to dump this thing out and get it back to Mr. Keith Rucker. All right, guys, I hope you enjoyed the tip on the squared around and the round around. It is a phenomenon, so if you're using a ball-tipped indicator up against a round, a small diameter round, there is an error that can exist. Okay, everybody, thanks for watching. Oh, is it ever going to stop? Okay, well, we've got the silicone out of the end. We've drained it. I've blown it out with compressed air. And there's all the coolant I recovered. Look at all that. It wasn't a lot. I'm going to sit that to the side. Now, let's make sure nothing funny happened. I want to check it again for squareness. Who knows what could have happened with all that coolant in there. I don't think it could really get under pressure or hydraulic the thing in any way, but let's check it again, make sure we get the same reading in the same spot. Let's take you over here, tip you down, tip our gauge up. And see how we do. Again, we're using our little flat-nosed indicator. I'll tip you up just a tad so you can see where the rubber meets the road. And get on this thing. It shouldn't have changed anything. I wouldn't think it would, but it doesn't hurt to check. Alright, we're on 0. Make the pull. Yep, looking real good. Same reading we had before. Awesome. Alright. Okay, we got our coolant drained, and I wanted to check it again for roundness, just to see if, make sure we didn't hydraulic anything in there. And I was always told to check on the side where you ground, but also check 180 degrees from that. I'm kind of out at the 3 o'clock position now. Very round at that end. And we're going to flip it around, come over here to the, what would that be, the 9 o'clock. And we need to be touching to do anything. These top adjusts are for the birds. I like the bottom adjust ones better. Okay, we're going to give that a little spin. So we're pretty good there. And here we're going ball to ball again, or circle to circle, but it really doesn't matter because we're not, we're going adjacent to the circle, so we don't really care. We're working our way around cylindrically. We're not trying to draw a line across a round. All right, we're at the bottom. This is supposedly as bad as it's going to get. But if your centers are cut round, it shouldn't give you any problems. So no tick there. So we've checked it on 3 sides. Let's go over here to... All right, we're at the bottom. We're going to give her a spin there. Wow, pretty happy. And top. And we'll give it a spin again. All that just to find out nothing's moving. Okay, so we ended up really round. The coolant being in there didn't have any effect on it. That's what I wanted to check to make sure that it didn't do anything stupid when I took the coolant out of it, hydraulic it, barrel shape it, who knows, or mess up the roundness of it. So that's a good trick if you're going to do a hollow cylinder. All right.